In this video, we'll generate the associated Legendre polynomials using Taylor series expansion in Google Sheets and Excel, which also can be used in Excel. So here we have this area, which is our expansion. This area is our coefficients. This will be our value of k, which is from 0 to n minus m. Our value of n will be data validation, 0 to 10. So these are values for n. So 0 to 10. Our value for m will be equal to data validation, list of items 0, 2, 4, 6. That will be our value for m. So these are values for m, 0, 2, 4, 6. So our formula for k will be sequence n minus m plus 1. That's the number of columns. One number of rows and one column starting from 0 incremented by 1. So if our m is 2 and our value for k is say 5, so it will be 5 minus 2 equals 3. So our n minus m will be 0, 1, 2, and 3. Next, we use the formula of the Taylor series expansion, which is equal to our formula series sum of the x values. So our x value is 1, x minus 1, x minus 1 over 2 raised to the power k, which is from 0 incremented by 1, and the coefficient will be this range. And we continue. There's 0.5 to the power m, so that's multiplied right outside series sum, so times. So in this you have 1 minus x squared to the power 2 raised to the power m over 2. That is m divided by 2. And the last will be, again, we have multiplication here. That's minus 0.5 to the power m. Now we can complete the coefficients, which is equal to RA formula. The first term will be factorial n plus m plus k. Enter. So if this is empty, this should be 0. So we correct this. So if k is empty, if k is empty, it should be 0. Otherwise, calculate. Now it's corrected. Next, we continue with the second part, which is combination. So times combine. Combine of n, comma, m plus k. So we've just completed the numerator part. Now we continue with the denominator, which has two parts. So divided by the quantity factorial n times factorial k. So we start from 0. At m equals 0, at n equals 0. So our value for y equals 1. So that's 1. At n equals 1, our value for y is x. At n equals 2, our value for y is minus 0.5 plus 1.5x squared. Our value for 3, n equals 3, that's minus 1.5x plus 2.5x cubed. We continue with we go n equals 2. So at n equals 2, we start with n equals 2. So our value for y is 3 minus 3x squared. So 3 minus 3x squared. At n equals 3, our value of y is, the polynomial will be 15x minus 15x cubed. That's 15x minus 15x cubed. N equals 4. It will be, our polynomial y will be minus 7.5 plus 60x squared minus 52x to the 4. So minus 7.5 plus 60x squared minus 52x to the 4. Now we go to n equals 4. M equals 4. We have 105x minus x squared, or minus 210x squared plus 105x to the 4th. So 105 minus 210x squared plus 105x to the 4th. If we use 3, which is lower, we have no data. N should be greater than m. So we use 5. Now we have our value for y will be 945x minus 1890x cubed, 945x to the 5th. That's 945x minus 1890x cubed plus 945x to the 5th. This completes the use of Google Sheets and Excel functions on array formula, Linus polynomial regression combined to generate, and sequence as well, to generate the associated Legendre polynomials.